Okay, so 51 says this. We have three pieces that make up this function. One of them is -3 minus x. This is graphed if x is less than or equal to 0. So that means to the left of the x-axis. Then I have 1. Okay. Did some of you not know what to do with that? 1 is a horizontal line of 1. Because if you think of it, y equals 1, just a horizontal flat line at 1. That one we were graphing for when x was between 0 and 1. And then x squared. What's x squared look like? A parabola? Okay. Cool. Now, oh, what's that? That's a line with a y-intercept of -3 and a slope of -1. Okay. So I am going to first do this part. I'm going to do that over here. Okay. I have to backtrack. If I had a y-intercept of -3, that would be here, and normally in algebra I'd say, okay, go rise over run, down 1 over 1, down 1 over 1, right? But if I do that, I'm graphing it in the wrong spot. That's graphing it over here. We want to graph it when x is less than or equal to 0. So let's backtrack a little bit. And this is a sketch, people. It doesn't have to be perfect. I'm going to go back 1, up 1. Okay, doesn't that have a slope of -1 then? Okay. So this is the piece -3 minus x over here, and I only graphed it there. Now, the 1. That, I am just going to go from 0 to 1 on that. So just a little piece from 0 to 1, and I'm going to make a horizontal line of 1. And I'm going to use an open circle and an open circle. Does anybody know why I'm using open circles? Because I used less than and greater than there. Okay? So that means that when there's just a less than sign, we leave that circle open. And then after that, I'm going to graph x squared. Well, normally, okay, I'm going to just trace and then I'm going to erase. Doesn't x squared normally look like this? But I only want to graph it from 1 on. So let's think here. What's 1 squared? 1. What's 2 squared? All right. So do you see how that hole became filled? Because now on this one it was a greater than or equal to 1. Was that helpful? Yeah. Okay. And these, like I said, these are sketches. So like if you were doing 49, 49 is cosine and e to the x. Let's just do that one a minute. So I'm going to do cosine. I'm going to do cosine to the left. By the way, cosine goes through 0, 1, correct? And then I'm going to just draw, it doesn't have to be perfect, just draw a cosine curve over here. But make sure that you make it go through 0, 1, because we know it does at the origin. And how about e to the x? E to the x is an exponential. E to the x, what's e to the 0? Anything to the 0 power is 1. So guess what? E to the x actually meets that curve there and goes up. Is this function continuous? No. Is this function continuous? Yeah. Some piecewise functions aren't and some are, depending on if they meet at those little points. Piecewise becomes super important in a calculus class. I'll ask you to do basic